Alright, coming to you live here before 5:30 in the morning. This is a lot of fun. Hopefully you guys get a little bit out of this video. We're solving trig equations again, so more of the same, they're just getting a little bit more complicated. You've done a few already. I'm going to start off with a double angle one. This one's kind of different. It can be a little bit tough. But we're going to solve for all x values between 0 and 2 pi. So I'm going to say I have the cosine of twice some angle minus 1 has to equal 0. Okay? You could use a double angle identity, but I don't know if that's going to help you a whole lot. It could possibly work. Maybe I'll try that both ways. But here's probably the way I would attempt the problem. I would add 1 to both sides. So the cosine of 2x is equal to 1. Okay? And then I would start to think or ask myself, the cosine of what angle is equal to 1? Okay? Well, the cosine is equal to 1 out here at 0 degrees. Or, again, at 360, or 720, or 1080. Okay? So, if this 2x value was equal to 0, because I know that the cosine of 0 equals 1. So if this 2x value equals 0, I know I'm going to have a solution. So therefore, I'm just going to set 2x equal to 0, solve this equation for x, and x equals 0 is one possible solution. If you're not sure, plug it in and check. What's 2 times 0? 0. What's the cosine of 0? It's 1. But that's not the only answer, and I want all answers from 0 to 2 pi. Now I know that the cosine of what angle equals 1? Well, the cosine of 0 equals 1. The cosine of 360 would also equal 1. So if this 2x value was equal to 360 degrees, it would also be a solution. If I divide both sides by 2, I get x equals 180. I know I'm in degrees right now, and I need to change back to radians, so x equals pi would also be a solution. Okay? Don't know for sure if that's correct. Take pi, plug it back in. What's 2 times pi? 2 pi. What's the cosine of 2 pi? Well, 2 pi is 1 time around the circle. 2 pi is right over here. The cosine of 2 pi is also equal to 1. So there's another solution. Okay? Let's go around the circle a third time. So 0 degrees is a solution. 360. If this was 360, the cosine of 360 is also equal to 1. 720 would also be equal to 1. So I'll set 2x equal to 720. Divide both sides by 2, I get x equals 360. And I know then that that is actually 2 pi. So x equals 2 pi would also be a solution. But if you look at my definition of where I want my answers, I only want answers from 0 less than or equal to x less than 2 pi. So I don't even want 2 pi as a potential answer here. It is an answer, but I only wanted answers between 0 and 2 pi. It would work. 2 times 2 pi is 4 pi, and the cosine of 4 pi would still be right over here. Okay, so that is still, the answer would still be 1, but not an answer we're concerned with. So the only two answers to this one would be 0 and pi. Alright? Another way to do that problem, like I said, I'll try it again here real quick. The cosine of 2x minus 1 equals 0. I could replace the cosine of 2x with one of its identities. One of its identities is 2 cosine squared x minus 1. And minus that other 1. I don't know if this is going to work or not. 2 cosine squared x minus 2 equals 0. Add 2 to both sides. Divide by 2. And then I could square root both sides. So that would be the cosine of x equals positive or negative square root 1, which would be a positive or negative 1. So then you could ask yourself, when is the cosine equal to a positive 1 or a negative 1? Well, at 0 degrees, and at 180 degrees, and then again at 360 degrees. So in other words, 0. So x could equal 0, x could equal 180, x could equal 360, which we know is 0, pi, and 2 pi, but again I don't want that answer there, so I get my two answers of 0 and pi. So another way to do the problem. Alright? So there's one type of problem using a double angle. You'll definitely see that on a test. Next example I want to do. Tangent squared x equals tangent x. Let's just solve for, again, let's just go 0 to 360. Let's use degrees this time. Right? All answers between 0 and 360. When you see a problem like this, you don't have anything set equal to 0, so I would move this over here to this side so I can get it set equal to 0. Because if you get things set equal to 0, usually they are factorable. What do both terms have in common that I could pull out the greatest common factor? That'd be the tangent of x. Notice if I would distribute that back out, I'd get right back where I started. The reason I did that is because once I factor it, I can set each factor equal to 0. So tangent x equals 0. Tangent of x minus 1 equals 0. When is the tangent 0? I'd be at 0 and 180. So x equals 0, x equals 180 degrees. Add 1 to both sides. Tangent of x equals 1. When is the tangent of x equal to 1? Well, that'd be a 45 degree in the first quadrant, and then again in the third quadrant, so that'd be 225. So x equals 45 degrees, and x equals 225 degrees. So those would be your solutions to this problem right here. So that one's not too bad. One more that you'll just love. 2 sine squared x minus sine x minus 1 equals 0. See how this would be very similar to this, but instead of sine x, we just have x here. This is like an algebra 2 problem where you hope it's factorable. It is factorable. If you don't know how to factor it, you can use that special factoring trick. A times c, I give you -2. Write down everything that multiplies to -2, but looking for what adds to 1. Obviously the only things that multiply to 2 would be 1 and 2, but what makes it add to a -1 would be a -2 and a +1. Divide those by the a value and reduce. So your factors are x minus 1 and 2x plus 1. If you don't believe it, distribute it back out. That'd be 2x squared plus 1x minus 2x minus 1, 2x squared minus 1x minus 1. Okay? So same thing as what we started with. So here are your factors for this algebraic one. Well, the only difference is here we have an x. Back here we have a sine x. So the factors are going to remain the same. Instead of x minus 1, I'm going to have sine x minus 1. And instead of 2x plus 1, I'm going to have 2 sine x plus 1. What do I do after I factor it? Set them both equal to 0. Add 1 to both sides. When is sine equal to 1? That'd be up at 90. So x equals 90 degrees. Again, we'll just go 0 to 360 here for our solutions. Subtract 1, then divide by 2. So sine x equals -1 over 2, or -1/2. That would occur, that's a 30-degree angle, but it's got to be in the 3rd and 4th quadrants. So that'd be 210 and 330. So x equals 210 and x equals 330. And there would be your solutions to that type of problem. Okay? No, I went through them pretty fast. Pause the video, come back to it if you need it. They should be very helpful in you being able to solve a majority of the ones in the homework. Your homework, page 4, 59, 19, 21, 23 through 27, 30, 31, 37, 45, 58. So, good luck. We'll please do what you can on these in class today. Once you've done watch the video, work together on it, okay? You guys will need some help with one another, okay? If you really have questions, you can definitely shoot me an email. I'll try to respond today and get back to you ASAP, but no promises can be made there. But I'll do my best. But please get most of these done in class today.